You can do these in order here, so let's do these. Combine those two first. You could, what could you do with that negative sign if you wanted to? You could distribute it. So you're going to have 7 plus 3i minus what? 4 plus 2i plus 3 plus I. So then how many i's do we have right there? 5i. And what about here? 7 minus 4 is? 7 minus 4 is? 3.
Mr. Seaman?
Yep.
Would you not subtract 3 minus 2?
No, it's the minus got distributed. So negative times the 4 is minus 4, but negative times a negative 2. See how it's negative right there? Negative times negative 2 is positive right there. So 3 plus 2i is 5i. And then you just have plus 3 plus I. So how many i's do you have? We have 6. Yeah, you got 6. It's fine. What about this? So what's the answer? 6 plus 6i. What kind of number is that? 6 plus 6i is a number. What's the... Well, 6i is imaginary. Together, what's the bigger name for all these numbers? Complex number. Yep. That's kind of like the catch-all for all numbers that you've seen are all complex numbers. But yes, it is imaginary. Why is it considered to be an Because there's an I in it. Exactly. Because there's an I in it, it is considered to be. Now this button is stuck. That's helpful. Complex number. That is imaginary. Yep. Okay, another one. Okay, so what should I do first on this one?
Use x1.
Yeah. So when you do this, you have to make sure you do not just bring in that square. It's negative 4 minus I. So what's that word? What's negative 4 times negative 4?
16.
Negative 4 times negative I.
4i.
And then you get the same thing, right? And then you get
I squared.
plus I squared, exactly. And then this whole thing is multiplied by what?
2i.
So let's keep simplifying what's on the inside here. How many i's do you have right there?
8i.
8i. What is I squared?
What, -1.
Negative 1, and this is still 16.
But you tried to tell me just I.
What's 16? So we have 16 and 1, so what is this? 2i times what? 15 plus? So that's going to be 30i plus I what? Squared. What is I squared?
15. Oh, negative.
Wow, that's a confident answer. That's somewhere.
Well, I was thinking of 16 minus 1.
But it's times, yes. So it's plus, so it's plus 16 times negative 1. So what do you end up with? Negative 16 plus 30i. What's the order that I like to put these in? What's the order that I like? I like to put it into a plus bi form. I like to put it into a plus bi form. And what's the order? I like having it a plus bi form. So what goes second? The imaginary part. The imaginary part goes second. The imaginary part goes second. Okay, any others? So what do? You have to, what's that word? Begins with a D? So you get negative 30i plus 10 what?
I squared.
But what is I squared? So that's plus 10 times negative 1. So the answer to this is going to be?
Negative 10.
Minus?
Minus 35.
Correct. Yes. Equals what? Yeah, we'll do one of these because we've done these so many times. Girls, this should be... I understand it's a lot of work, but can you reasonably expect to see one of these on your test? Yeah. So at this point, you need to square both sides. So if you square both sides, you end up with 11 plus 2x plus 2 of them plus what? 1 is equal to, I squared both sides. So the first thing was square both what? Sides, not each individual thing, sides. So now you clean it up a little bit. So that cancels, leaving you with 10 plus 2x. This goes away. I'm sorry. Why was it still there? You're like, that doesn't help me. That makes it worse. You're wrong, Mr. Seaman. Yeah, I got it. So you end up with, let's subtract the 2x, and so that becomes a 10 over here. If I do this, this becomes a 3x. So you get 10 plus 2 root
11 plus 2x.
Equals 3x. What should I subtract from both sides?
10.
Yes. Plus 2x is equal to 3x minus 10. Now what should I do to both sides? Yeah, square. Well, you could divide by 2, and that's fine. You create fractions if you do that. You don't have to. So let's just square both sides.
If it's like perfect and they're both
Yeah.
equals of
then divide. Yeah, sure, absolutely. But if you divide by 2 now, you're going to have a 3 over 2. Just wait till the end. You just have to square properly. What does the left side become?
4
Yep.
times 11
Mm-hmm.
plus 2x.
So then you just have to do this out. So it's 3x plus 10, not plus, 3x minus 10 times.
3x minus 10.
Exactly. So this is going to be 9x squared minus 30x plus 100. Do you get kind of sad when you see big numbers? Maybe, but hopefully they'll go away. 44 plus...
I get sad when I see a coefficient not of 1.
Yes, that's correct, but guess what? We've done this exact one before.
All the time.
We have 60x plus 100. What kind of equation do we have now?
A quadratic.
We do have a quadratic. So what's our what method are we trying to use? Begins with an F. We'd like to,
Factor.
but before we factor, we need to.
Make everything 0.
Mm-hmm. So let's subtract 8x.
Wait,
Subtract
what's the F word for
factor.
that? But you said before we
No,
factor, we have to use it.
No, I said what's our first step? Begins with an F factor. What do we do before that though? You just brought both statements together. So 0 is equal to 9x squared minus 68x plus 36. No, 56.
Yeah.
So then you just have to factor this, right? And is it kind of annoying that the leading coefficient isn't 1? Sure. But then there's only 3 and 3 are 9 and 1.
Would you not let us use our calculator?
This would, no, you would absolutely have to be able to do this. You're not gonna have your calculator, so this could happen to you. So you have 0 equals, and I think it's 9x and x, I think.
Yes.
And it's both gonna be negative, I think.
Yes.
So how about minus 7 and minus, that's too big it seems like. Did anybody do this one?
I messed up.
Yeah,
I messed up.
Bro said let's check the math. Well, what did we forget? What did we forget?
The plus 1.
That plus 1 we forgot, so what should it actually be?
It's
11.
9x squared minus 7, 4x plus 7, 7.
It's going to be 3x minus what?
So how much of that was unnecessary?
Hold on one sec. When I'm saying something out loud, and it's particularly a question to all of you, it would be great if you could either answer it or acknowledge that I just said something to you. I understand that sometimes I don't look at you because I'm looking down at this and asking you a question. But these two, it should be 3x minus 11. Yes, so therefore, what should we have to do? Oh, look, it's all gone. Magically all gone. Is it all going to be very similar? Yes. So yes, we needed to clean that up. So what do we end up with? Now, good catch, Gabby, by the way. 11 plus 2x. This is going to be 9x squared minus 66x, right? 33 plus 121. So 44 plus 8x equals 9x squared minus 66x plus 121. So 0 is going to equal 9x squared minus...
No, x.
The 9x squared stays the same. We're subtracting 8x, so it's going to be minus 74x.
Yeah.
And then what's 121 minus 44? Can you do that in your head?
Yeah, it's 67.
I think it's 77.
77.
Now does this factor? Yeah. Have we done this exact factoration before? Yeah, that's what I was kind of expecting and forgot that one. And it's 9x and x, I think, right? I think it's minus 11 and minus 7, right? 63. Yep, it is. So what does that tell you? The zero product says that, zero product property says that, or, so what are the two answers? X equals 11 over 9, or X equals 7. And then what do you have to do? Check. We won't do it now, we have to check. Good catch. It seemed a little off. Yes, go ahead. So you multiply those two together, and what do you get? 11 plus 2x. Square root of a table times the square root of a table is a table. And then you get the same thing twice. So how many is that? That's 2 of them. And then what's 1 times 1? 1. So that's where, I'll do some color here. This right here, it comes from there. To multiply by the conjugate. So can someone tell me what that's going to be? Radical 7 minus root 5 over root 7 minus root 5. It has to be the same on the top and bottom because what does this need to be? It has to be 1. That's a form of 1, so you have to flip the sign. So you see how it's a plus right here? It needs to be a minus right there. So now when we distribute this, you have to make sure you distribute. What's 8? Oh, it's going to be 8 root 7 minus 8 what? Root 5 all over. Well, what's root 7 times root 7? 7 plus root, yeah, well, hold on. I'm just going to do the canceling. Root 7, root 5, minus root 7, root 5, minus what? 5. What cancels? What's the nice thing that cancels right there?
7, 5.
Yeah, the middle. These go away, leaving you with 8 root 7 minus 8 root 5 all over what? 7 minus 5 is, yes, girls, it is 2. So what does this simplify to? 4 root 7, 4 root 5. Leave it like that.
How?
Can you do it?
Happen that step?
Which step?
That when you just did 4 root 7.
Yeah.
What's 8 divided by 2? What's 8 divided by 2?
It's 4.
That's all it is. It's just 2. I mean,
but can't you subtract them because they have the same?
no, they,
Oh, wait, no,
7 and 5 are not equal.
Yeah,
5
you need
not
the
equal
same-
7.
You need the same if they-
Correct. They have to be the same. The power is the same, but the base isn't the same. Okay, kids, go up to the board. Find a space on the sides, please. I'm going to give you one to work on here. No, you're doing up there. Come on.
Get lost.
Oh, you don't want to work with me?
There it is, kids. Say I started at the North Pole, and I walked down all the way to the equator, okay? Straight line. I turn 90 degrees, and I walk all the way over to the prime meridian is what it's called. I think it's prime meridian.
Yeah.
And then I turn 90 degrees, and I go back up. So what's the angle measure right here? Well, that's 90. What's the angle measure right here? 90. And what's the angle measure up here? So what's 90 plus 90 plus 90? That's 270, right? So do you agree? I walked straight down, I turned 90 degrees. Okay, what shape is that green shape? What's the sum of the internal angles of a triangle?
180.
What did we just show it is?
270.
On a sphere,
Because of 3.
on a sphere, guess what happens? It depends on the size of the triangle. If I make the triangle smaller, what does the internal angles add up to? Something smaller than 270. Do you see these points right here? Let's say I had 3 points. I could pull the point back. What's going to happen to this angle? It's going to get bigger, right? How far can I pull those points back?
All the way around.
I could pull this. I could pull that point this way, right? Pull that point that way and pull that point that way. You could pull them all the way back, and then they'll meet, right?
Yeah.
If they meet, what's the angle sum going to be? 360. So on a sphere, the angle measure can be between 360 and 180, depending on how big this triangle is. Bigger triangle, more angle. So the geometry that you work in, it's called Euclidean geometry. It's on a flat surface. When things are flat, very nice. But when you start bending, it gets really fun. You like that? Good. Okay. Well, thank you very much for visiting. Definitely email if you have any questions. 谢谢. 再见. I'm doing literally what you just did. 2 plus I over 2 plus I. What's that a fancy word for?
The conjugate.
Complex conjugate.
Yeah.
So I'm doing what you guys did over there. So now what do I have to do? Distribute. So it's going to be 4 plus 2i plus 2i plus I squared over 4 plus 2i minus I squared plus, thank you, that's a good catch, I minus I squared over what? Ones and i's are hard, aren't they? 1 minus I plus I minus I squared. That's why I hook mine too. So then you have this. Are there lots of things that can't...
Are you supposed to put an I squared on the other one too? That you didn't?
Yes, I am. So now we need to simplify. So what does the top become on the first one? 3 plus 4i, I think? Because this right here is what? And that's negative 1 too. So this over what? 3, I think? It's just over 3, right? Because this cancels? Or is it 5?
No.
Ah, what does that come out to be? That's a minus a negative 1, so it's going to be 5. So then what's it come out to be over here? I what?
Plus 1.
Plus 1, right? Over what? This cancels, and you have minus I squared, so that's minus a negative 1.
Plus 1 is
2. Like this. To add fractions, what do you need?
Common denominator.
So this is going to be 3 plus 4i over 5 times what?
2.
Over
2.
2 plus I plus 1 over 2 times,
5 over 5.
yeah, and this is all times what?
I.
Times I. So these get multiplied, both of them. So what is it? 6 plus 8I over 10. 5I plus 5 over
10.
times what?
I.
I. So how many i's do we have? So we have 11 plus 13i over 10 times what? So you end up with 11i plus 13i squared over 10. So what do you end up with? Negative 13 plus 11i all over 10. There it is. Square root of negative 100, that's just going to be negative the square root of negative 1, the square root of 100. What is the square root of negative 1?
Negative
1 over radical 1.
No. What? Guys, it is I. Yes. So what is this? Negative I root 100 over I root 25.
which is 5.
Yes. So what does this turn into? Negative 10i over 5i. What cancels? So what do you end up with? Done. So the only thing I really want you to take away from this, when you see the square root of negative a, what can you write it as? I times the square root of a. That's the big takeaway.